Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Asyraf bin Muhammad SAFIE. My matric number AE200100. So this is the video presentation for our group DSP project. So we are from group 7 and this is our team members Muhammad NAZRAN, SITI NURAIN and FAIZATUL FARIESYA. So for introduction, digital signal processing or DSP techniques play a vital role in the design and implementation of filters, which are fundamental components in signal processing systems. Filters are very important tools used to remove unwanted signals, amplify desired signals, and extract relevant information from digital signals. They have several uses in fields including telecommunications, image processing, and audio and video processing, and many others. Filters can be implemented in both analog and digital domains, but compared to analog filters, digital filters provide a number of benefits such as flexibility, precision, and ease of use.
Assalamualaikum. My name is FAIZATUL BINTI LAELANG. My matrix number is CE200191. So I will be continuing to the problem statement. In this project assignment, we need to design our own problem by using FIR, or also known as a finite impulse response, in order to reduce the noise signal. We try to solve it by using manual calculations and then try to compare it by using MATLAB. Next, we attempt to run it in Arduino to clearly see the outcomes and to offer plotted visuals of both the filter and unfiltered signals. So we need to filter the given input signal with n equals to 5, fc equals to 8 Hz, and s equals to 20 Hz by using finite impulse response.
So for our group objective, the first one is to understand the concepts and principles of digital signal processing techniques and their application in filter design. And number 2 is to design and implement a simulator of a filter system using a microcontroller board or Arduino, demonstrating proficiency in digital signal processing techniques. And last but not least, to explore and analyze the theory and concepts of finite impulse response filters and evaluate their performance in the design filter system.
Assalamualaikum warahmatullahi wabarakatuh. Very good morning. My name is Muhammad NAZRAN bin Muhammad NASRON, matrix number 200178, and today I'm going to present about the methodology part of our projects. The filter we designed in these projects are low-pass FIR filter. Because of this feature, FIR filters are innately stable and offer fine control over the frequency response. We also using the Bartlett window because it is symmetric and evenly weighted response, have good side lobe suppression, computational efficiency, and the ease of implementation, make it well suited for attenuating higher frequency while preserving the lower frequency in a low pass filter.
Next is for the manual calculation. I will explain step by step. First, we need to find the value of fc, which is fc equals to s, 8 equals to 20, and we get the result, which is 0.4. And then, as you can see here, by using n equals to 5, we put it the value 5 inside the formula of m, and then try to calculate it. We get -2, and also negative 2 and also 2, and then we get the result here, n equals to -2, -1, 0, 1, and 2. So next, we try to calculate by using a Bartlett window. As you can see here, this is the formula of Bartlett, and then we try to insert the value of this n inside the formula, and then get the result, which is 0, 0.5, 1, 0.5, and also 0. So for the HLP, for the low pass filter, 2fc sine 2 pi fcwn. So we also insert the value all the value here, FC, and also the value WN inside the formula of HLP, and then get the result 0, 0.35, 0.8, 0.0935, and 0. So as you can see here, this is the step-by-step manual calculations.
Assalamualaikum Doctor, my name is SITI NURAIN binti ROSLI, my metric number is CE 2086. Now I would like to present about the result and analysis. This is the two software we are use, MATLAB and Arduino IDE. In this MATLAB, we have a graph raw versus filter value, phase response and frequency spectrum. In this filter, raw versus filter values graph, in the red color is a filter value and the blue color is raw value. Is present a smoother trend than a raw data, and then the smoother signal is evident than the high frequency component was successfully reduced by the FIR low pass filter. And then for the phase response plot, display the insertions of the phase shift, characteristic of FIR filter, and then for the frequency spectrum, amplitude response of the filter is displayed in the frequency spectrum. This is reveal how well the filter can attenuate frequency that are above, like that cut off frequency. The important factor like the cut off frequency, passband ripple and stop band attenuation are easily evaluated in this figure. And then in our group, the supply filter coefficients in the low pass filter with a reasonable simple response. And then for the Arduino IDE, for the Arduino IDE, we connect with Arduino Mega 2560 with the potentiometer as a frequency to get this graph. For the red color is for the raw data, and then the red color is a filter data. And then as a result, the filter ability, and this observation was successfully done with in our group. As we can compare which is the best one, is the software or hardware result. Our group can conclude that the software digital filter versus hardware digital filter, the two approaches can give an analytical result. So this is the pro and con. This means it's depend on our situation.
So now we will move to MATLAB coding. So this is our coding for step 1. We are using FIR low pass filter. So N here is the length of filter, which is we use 5, and FC is cut off frequency, we use 8. S is sampling frequency 20, and N here represents the value represents the discrete time indices of filter, and FC here is the normalized cutoff frequency, and the W here is for Bartlett window, and HLP here is to calculate the impulse response of low pass filter, and lastly frequency here, frequency Z here is to used to plot the frequency response. So we will run the coding, and this is the graph that we obtained from the coding. The first one is magnitude versus frequency, and the second one is phase versus frequency impulse response. And this one is the coding for step 2. So this raw data is the sample data and parameters. Fs here is the sampling frequency, and filter coefficients is the example of filter coefficients. We use this value, and this is the FIR filter parameters. This one is to initialize the variables, raw values, and also filtered values. So to apply FIR filter, we are using this section of coding. So we shift the values in raw values array to the right, and this is to apply the FIR filter into the filter values. And this part is to calculate the phase response, and this part is for calculate the frequency spectrum, and the remaining part is to plot raw and filtered values, phase response, and frequency spectrum. So we will run the coding, and this is the impulse response that we get from the coding. The first one is raw versus filtered values. So the raw one is the blue line here, and the filtered one is the red line. And this is the graph for phase response, phase versus frequency. And lastly, this is the graph for frequency spectrum, which is magnitude versus frequency. So that's all from me. Thank you.
Now I would like to demo at the Arduino IDE software. We include the cost in INT analog input into the pin A0 for the output pin. At the Arduino, we connect to 9. After that, filter size we set 5, and the filter coefficient filter size we put 0, 0.5, 1, 0.5, and 0. After that, we include the array to store the raw analog value, and then we put the program for the filter analog value. After that, we initialize the raw value array with 0. After that, we put the loops, and then the shift. This is a program where the shift value in raw value array to the right. After that, we put the program that is read the new raw analog value. After that, the last one, we apply the FIR filter. This one, filter value equal to filter coefficient multiplied with raw values. And this program we will have an output the raw and filter value, and then the output the filter value as a PWM, and the last one delay, we put delay 10 seconds. Firstly, we need to verify the program. And then we upload the program. And then in this project, we connect to the Arduino Mega 2560. And then at the port, we connect to the COM4. And we go to the serial plotter to see the raw and filter value. In the right one is a raw value, while the left one is the filter value. So for example, 560 minus 356, so we can get the difference is 204. And go to the serial plotter to see the graph, and we run the program. Now this is the graph before we connect with the potentiometer. Potentiometer is as a frequency. This is the graph. We can see that the graph is not very okay. And then this is the graph when we connect with the potentiometer. We have a frequency. This graph has a frequency, and then we can see that the blue one is a raw value, while the red one is the filter value, which is the raw value. The waveform is a big compared to the filter value. The filter value have a small waveform. The main reason to filter a signal is to reduce and to smooth out the high frequency noise associated with the measurements such as pressure, flow, level, or temperature.
Finally, the conclusion of our project. In summary, the Digital Signal Processing project has highlighted the critical role of filters in DSP and communication system. The project emphasized the application of FIR and showcasing their respective advantages and common usage scenarios. Ultimately, the selection of FIR filters for project enabled successful signal processing and achieved the desired objective. That's all for us today. Thank you for watching.